Hi everyone, my name is Fabianus Sebastian from class 1D, and today I'm gonna present about image quality in digital radiography. Okay, so here I'm gonna present 3 points. The first one is about spatial resolution, the second is distortion, and the third is exposure indicator. Okay, so the first one is spatial resolution. Spatial resolution is in digital imaging is defined as the record sharpness or detail of the structure on the image, the same as defined for film screen imaging. Resolution in a digital image represent a combination of the traditional factor for film screen imaging as focal spot size, geometric factors, and motion, and just as important, the acquisition pixel size. This pixel size is inherent to the digital imaging receptor. The smaller the acquisition pixel size, the greater the spatial resolution. Spatial resolution is measured in line per millimeter. Current digital imaging systems employed for general radiograph have spatial resolution capabilities ranging from approximately 2.5 LP per millimeter to 5.0 LP per millimeter. And this is a picture about high spatial resolution with high visibility. The middle one is a picture of a high spatial resolution with low visibility. And the last one is a low spatial resolution with low visibility. So the second one is about distortion. Distortion is defined as mispresentation of object size or shape as projected onto radiographic recording media, and the factor that affects distortion are X-ray beams, centering, source image receptor distance, and object image receptor distance. So the first factor is X-ray beam. The X-ray beam originates from a point source within the X-ray tube. It is to this point source that X-ray beam will all possess beam divergence. As the beam exits the X-ray tube, the beam will diverge, while the central point of the beam will not suffer from any divergence. All regions peripheral to central ray will then suffer from some degree of distortion. Okay, the next factor are centering. Centering the anatomy to the central on the image receptor will limit beam distortion to the divergence. The point of central ray is a focal spot on the X-ray tube. Therefore, no one can angle the tube on the stationary axis and maintain the central ray at the level of the joint. Seldom applied but useful from imaging that require no longer graphics. So the next one is source image receptor distance. The source image receptor distance, or SID, is the distance between the tube from the image receptor that affecting magnification. The greater the SID, the less magnification the image will suffer. Although 100 cm is the universally accepted SID, studies have shown that apart from improving distortion issues, increasing the SID from 100 cm to 122 decrease increase the skin dose despite any need for increase in MIS. The next factor is object image receptor distance. So the object to the image receptor distance, or OID, is the distance between the object to the detector. The closer the anatomy is to the detector, is the less magnification or distortion. One can observe this when observing the shadow cast by light source onto the anatomy. And this is a picture about different distortion at different range of distance. Okay, so the last one is about exposure indicator. The exposure indicator in digital imaging is a numeric value that is representative of the exposure that the IR has received. Depending on the manufacturer of the system, the exposure indicator may also be called the sensitivity number. The controlling fact: the exposure indicators depend on the dose of the radiation that strikes the receptor. It is a value that is calculated from the effect of mass, KV, the total receptor area irradiated, and the object exposed. Depending on the manufacturer and the technique used to calculate this value, this exposure is indicator for display for each exposure. An exposure indicator as used by certain manufacturer is inversely related to the radiation that strikes the receptor. For example, if the range of acceptable image for certain examination is 150 to 250, a value greater than 250 will be indicated under exposure, and value that less than 150 will indicate overexposure. And next is overexposure indicator as used as the manufacturer directly relate to the radiation striking the ER as determined by logarithm calculation. For the example, if an acceptable exposure indicator is typically 2.0 and 2.4, an indicator value less than 2.0 would indicate underexposure, whereas indicator value greater than 2.4 would indicate overexposure. So this is a picture about overexposure radiograph, the optional, the overexposure, and the extremely overexposure radiograph. That's all from my presentation. If you guys have any question, you can ask in the comment down below, or you can DM me on my Instagram. So that's all I can say. Bye bye.